All right, so in this section, we're going to be looking at functions, rational functions, horizontal asymptote. Now, the vertical asymptotes are fairly easy to find. You just factor the denominator and look for places where, the denominator would equal 0. Keeping in mind that if you also have a shared factor in the numerator, that you don't get a vertical asymptote there. You just get a discontinuity. Now, horizontal asymptotes are a little bit different. A horizontal asymptote looks for what the function does, towards positive infinity and towards negative infinity. All right. It just wants to know, you're actually allowed to cross the horizontal asymptotes. The function's actually able to touch there. That's one of the major differences between it and the vertical asymptotes. But for the horizontal, we're just trying to find out what value is it approaching or heading towards as it goes off to positive or negative infinity. All right? Now, in some respects, the horizontal asymptote's pretty easy. There's 3 cases. I think we're just going to go through the first case here on this first video. So, in the first case, we're looking at the degrees. All right, the degree of the numerator compared to the denominator. If the degree of the numerator is less than the degree of the denominator, then you will always have a horizontal asymptote at y equals 0, which is basically your x-axis. All right, so it'll always tend towards this line. All right, so you'll notice in this first example, we have a degree of 1 on top and a degree of 2 on the bottom. So automatically, I know that this is going to have a horizontal asymptote at y equals 0. Okay. On this one, if we're looking at the top, we see 2 linear factors, so it has a degree of 2. And on the bottom, we see 3 linear factors, so it must have a degree 3. All right. In both of these, we're saying that the degree of the numerator is lower than the degree of the denominator. So it would have, again, a horizontal asymptote at the x-axis, y equals 0. So it's allowed, in these, it might actually cross the x-axis. It might actually touch the x-axis, but it's not guaranteed, all right? So what you want to look at next is the range, all right? Now the range, finding the range for these is not nearly as easy as finding the domain. So what we're going to do, we're just going to graph these and look at the graph to determine. There are some ways to find the range algebraically, but they're pretty intense, and it really changes depending on what kind of denominator you have. So let's look at the graph of our first one here. All right, you see it's got a very funky graph. There's no vertical asymptotes here, so it doesn't actually blow up anywhere. But if we look off towards the negative infinity direction, we can see here that the y values are staying pretty close to 0, right? Not sure if it actually touches 0 here. It looks like, actually, if we zoom in here, you might be able to tell. Yeah, I see on the left side of -6, we're at some negative value for the y, and on the right side, we're at some positive value on the y. So it must actually cross somewhere in here. All right, it looks like it's at -4. And that makes sense, because at -4, we actually have, an opportunity for an x-intercept. All right, and if you look off towards positive infinity, we're looking like the same sort of thing. It's getting closer and closer to 0, but not actually touching it. Remember, our only opportunity for an x-intercept was here at -4, so we're not going to have an x-intercept on this side. It's just going to get closer and closer to 0 as it drifts off to the right. All right, so it actually does get to 0 on this side. And if we look at our maximum here, our maximum would be 6.041. Okay, so if we were trying to describe the range, it would be some value including 0 at least, some value below 0. We can see here it's actually reaching a negative y value. And on the top side, it would be something like positive 6.041, and it would actually include that. Right? If we were looking at our second function, you see it blows up here. It's got a vertical asymptote there and there. It's horizontal asymptote, so you can see it's at 0 here. It's on the x-axis, and the same for on the right side. If we were trying to describe the range here, well, you'll notice at this spot it actually blows, up downwards in the negative infinity direction. So it actually does go towards negative infinity right here. And if you follow it, it will blow up towards positive infinity on this one. So in this case, the range would be all real numbers because it has y values towards negative infinity all the way up with no discontinuities towards positive infinity.